All right, so we are going to look at some more examples of compound inequalities. So it's a lot like yesterday. We're just going to have some multi-step or variables on both sides. A lot of practice you're going to be doing on your own. But to start, we are going to look at a lot of different situations that can happen on our graphs. So remember that both inequalities have to be satisfied. And for or, only one of them needs to. So for the first one, it is helpful sometimes while you're still learning to kind of separate these. So x is greater than x is really the same as x is less than 8. And x is greater than or equal to 3. So as I'm talking, I'm going to be saying x is less than 8. That's just because I'm able to kind of read it backwards. So keep that in mind as I'm working and talking. All right, so let's go ahead and number our number line. We got 3, 4, 5, 6, 7, 8, 9, or you could have started with 2 and ended with 8. You just want to make sure that both numbers are on the number line so we can graph on both of them are open or closed circles. So for here we have x is less than 8. So I'm going to have an open circle, and I know that's pointing this direction. And remember, I know this is an and because it's written together. Ors always have the word or. If it's an and, it'll say and, or it's written together. So, and x has to be greater than or equal to 3. So we're looking for that overlap, and the overlap is between them. That is the part of our number line where the solutions are, because that is where it satisfies both of the inequalities. So go ahead and make sure you got that copied down. I'm about to clear it and move on to the next one. And remember, you can always pause if you need to. I'm not going anywhere. This is pre-recorded. You just pause and play and replay as many times as you need. All right, so let's look at the next one. So the next one's a funky one. We have x is greater than or equal to -2, and x is greater than or equal to 3. So yesterday, when we were learning and working together, we had an or statement where the inequalities were pointing in the same direction. We have not had an and like that yet. So this is going to be a little different. So -2, -1, 0, 1, 2, 3, 4. Or you could have started with -1 and worked your way up to 5. Doesn't matter. Okay. So we have -2 here. And we need all of our values to be greater than -2. And I'm going to change my color so we can make a point here. Instead of graphing them separately and then together, we're just going to use two different colors for now, just to explore. And x has to be greater than or equal to 3. Now, this is an and, meaning that it has to satisfy both. This area right here only satisfies one of them. Whereas here, when they start to overlap, now it's satisfying both of them. So for this one, I know the numbers are going to be gone. Sorry about that. I'm just going to put 3 right here. I don't know if that's where it was. Sorry if it moved. But since it has to work for both of them, all of the ones that were greater than or equal to 3 is the only time it's going to satisfy both. So like a 2 here. 2 is greater than or equal to -2, but it's not greater than or equal to 3. So where they start to overlap from earlier is going to be the one we keep. So when it was an or, the one that contained the other one is the one we kept. Here, we look for where they overlap, so where they both become true. In case you're wondering why I said 23, it was just because I was numbering it. Okay. So make sure you have that copied down. All right, let's look at another example. All right, here we have x is less than 2 and x is greater than 5. So 1, 2, 3, 4, 5, 6, 7. So x is less than 2 and x is greater than 5. Now, that looks normal. We've graphed a ton of those yesterday, but the problem is this is an and. and there is no overlap. So since there's no overlap, this will be a no solution. There is no number that could ever satisfy both of those at the same time. 6 satisfies the greater than 5, but it's not less than 2. 1 is less than 2, but it's not greater than 5. There's no overlap, therefore it is a no solution. Make sure you got that copy down. And technically you would just have a blank graph, but I wanted to show how it would look and why it didn't work. All right, moving on to our ors. We know they're ors, like I said, because they say or. All right, so 2, 3, 4, 5, 6, 7, 8. X is greater than 2. Or, let's change color. Fancy. X is greater than or equal to 7. So they're pointing in the same direction again. But since this is an or, only one needs to be true at a time. This is where at least one of them is true. So for our graph, 1, I can't remember how I had it numbered. Sorry about that again. I keep doing that. All right. So if it's greater than 2, then it's always going to be greater than 2 or greater than or equal to 7. All right, make sure you got that. Whoop. All right, there's 2 more. Oops, we'll keep it green. All right, we got x is less than 5 or greater than or equal to 2. So 1, 2, 3, 4, 5, 6, 7. All right, so x is less than 5 and x is greater than or equal to 2. Do you notice something? The arrows are going in both directions forever, and they overlap. Everything is included. There is never going to be a number that does not satisfy at least one of those. Let's try it. 1. 1's less than 5. Doesn't matter what the other one says. 7. 7's greater than or equal to 2. Doesn't matter what the other one is. How about one of the ones where their overlap is? 4. 4 is less than 5 and greater than or equal to 2. And for ors, it's okay if both are satisfied. The rule is that only one has to be satisfied. At least one has to be satisfied. So if we kept going, over here is negative 100. Negative 100 is less than 5. Doesn't matter that it's not greater than or equal to 2 because it only has to satisfy 1. Over here, 182. That's greater than or equal to 2. Doesn't matter that it's not less than 5 because it only has to satisfy 1. So this is another special circumstance. We love those. I love those. 1, 2, 3. Once again, sorry if I numbered it different. 6, 7. It is going to be the whole thing because this is an infinite solution. All real numbers. With the conditions given, there will never be a solution that does not satisfy at least one of them since it is an or. Make sure you got that copy down. We're about to move on. All right. Last circumstance that you will run into. Boop. All right. 2, 3, 4, 5, 6, 7. Guys, are you impressed that I can count? I mean, I have a master's degree. This is what you get. I'm just kidding. All right. So x is less than or equal to 3 or greater than or equal to 8. And this is the traditional one that you will more than likely see is the one where they look like oars, like on a boat, or a kayak or whatever those boats are. Anyways, that are pointing in opposite directions. One or the other has to be true. Doesn't matter that there's never going to be a time where they're both true. It's okay. All right, so we saw that there was a regular overlap. We saw that they point in the same direction for and you drop You keep the one where they start to overlap, and then you saw one where they're in the same opposite direction, so it's a no solution. And then for ors, you had the traditional, you had where it ended up being an infinite solution, and you had where they're in the same direction, and you drop the one that is included in the other one. Okay, so if you're watching this video, you've already been in class, or you're not here. So I'm going to do a couple just in case you're not here. These are all one step. Those are pretty easy. I just want to do one with you that's a little trickier. Here we go. Let's try this guy right here. So this is an and, it's written together. And just think of this as a two-step. So like this is this is the expression you're trying to isolate the variable in. So you can see that there's two things being done to n that we're trying to undo. So this is really just a two-step inequality. It's just the fact that we're going to have to do it to multiple sides instead of just two sides. Now I'm going to change the color, make it pretty. All right, we're going to draw those lines here. Oops, I don't really like that. Draw the lines there. Okay, cool. Change the color again and zoom in. So the first thing you do to get n by itself would be to remove the constant. So we're going to add 12. You just have to add it everywhere. Cancels. Negative 7n is less than negative 14. Just using my integer rules. And over here, negative 21. 21, 31, 32, 33. Yep. All right. And we're going to keep those inequality symbols. And then let's change the color one more time to show the last step. To get n by itself, we're going to have to divide by negative 7. Well, since we're dividing by a negative, we're going to have to flip the inequality. But here, we're going to be flipping two of them. So we're going to end up with 3 is greater than or equal to n, which is greater than 2. And that's going to be what we're graphing. This is not a whole lot of space. So if you want to like copy these on a separate sheet of paper and just use this for the graph, that's up to you. All right, so let's go ahead and graph it. So it's an and, so we need to look for overlap. So n is less than or equal to 3. So less than or equal to 3. And it's greater than 2. So we're looking just for the overlap. So one thing that might be helpful is using pencil or doing the two separate graphs and then putting it together. Because now we have to clear everything and do that again to show the final. And the final is, crud, I lost everything. 12, okay. I think it was greater than 2 and less than or equal to 3.